my name is Catherine Huber Ratliff, and today's date is January 13th, 2020. So today we're going to be talking about feedback loops in the non-gravid female reproductive system. So to start, I want to review the ovarian and uterine cycles. So there are three phases in the ovarian or menstrual cycle. The first is the follicular phase, which we see here. And during this phase, we have follicular growth from the primary follicle, which we see here, to the dominant follicle, all the way till up right before ovulation. During the follicular phase, estrogen, as we can see here, is the predominant hormone, although there are still varying levels of the different hormones throughout the follicular phase. And this phase typically lasts anywhere from 10 to 21 days for most women who are having healthy, regular menstrual cycles. During the follicular phase, we also see that there is a decrease in the basal body temperature compared to later in the luteal phase, where we see this rise in basal body temperature. Now, the second phase is considered ovulation, and during ovulation, what we see here is right before this, we have a surge in both luteinizing hormone and follicle stimulating hormone in that late follicular phase, and that stimulates ovulation. So we can think of ovulation as being dominated by FSH and LH, although estrogen has also just peaked right before ovulation too. And then right after ovulation, we have this temperature spike that we see down here as well. Now, the final phase of our ovarian or menstrual cycle is the luteal phase. And this is when we have the ruptured follicle that turns into the corpus luteum and then progresses into the corpus albicans. And that helps to prepare the body for pregnancy if that were to happen at this cycle. That ruptured follicle, the corpus luteum, then turns into a secretory gland, so to speak, where it does secrete hormones such as progesterone and estrogen and inhibin that we'll see as well. The temperature spike that we see right after ovulation remains high throughout the luteal phase, and you'll also see that we have kind of the buildup of the endometrium as well, which we are going to talk about now. So that was what we might consider our ovarian cycle, and then we also have our uterine cycle, which is regulated by these different hormones throughout the entire on average 28 days. So of the uterine cycle, at first we have menses, and at day one, this is what we consider to be day one of the entire cycle, and that's when the shedding of the endometrium layer starts, which starts menstruation, and then after that ends, so typically that's anywhere from 3 to 7 days for most women, then we transition into what's the start of the proliferative phase. And that is the second half of the follicular phase, where the endometrium begins to add new layers of cells. And then, as we talked about with the creation of the corpus luteum, then the uterine, kind of the endometrium uterine lining turns into the secretory phase. And that occurs during the luteal phase, where hormones that are released from the corpus luteum trigger the secretion of additional hormones from the endometrium that then turns this into a secretory structure as well. So before we go into all of these different phases in more detail and look at the different hormones involved, I thought it would be helpful to just review the overall hormonal control of reproduction. So for the female reproductive system, we can think of this as the HPO axis, the hypothalamus, the pituitary, and the ovarian, or the ovaries. So in the hypothalamus, we have the release of gonadotropin-releasing hormone that we will call GnRH, and that travels and acts on the anterior pituitary to release both luteinizing hormone and follicle-stimulating hormone. Both of these then travel to the gonads, here the ovaries, and follicle-stimulating hormone, as the name implies, kind of works on works with steroid hormones to initiate and maintain the production of the follicle and the oocyte, or the egg. And luteinizing hormone acts on kind of the endocrine cells and stimulates the production of sex hormones, here being steroid hormones. Both of these operate under different feedback loops. So we have a short feedback loop here where the gonadotropin provides negative feedback on the hypothalamus to reduce the gonadotropin releasing hormone. And then we also have these longer feedback loops as well. So if we see that there is a drop in estrogen, this, as we can kind of see here, this will trigger an increase in LH and FSH ratio by the, amounts by the anterior pituitary to help to produce more of these steroid hormones. Now, if there's a rise in estrogen, the effects are dependent on the amount of estrogen that is in the system. So moderate amounts of estrogen exert a negative feedback to the anterior pituitary and the hypothalamus. However, sustained estrogen levels will actually exert a positive feedback loop on gonadotropin releasing hormone, which will further stimulate LH and FSH, which will produce more estrogen. And we're going to see how this happens as we go in a little bit more detail here. So now we're going to take a closer look into all of the different hormones and the roles that they play throughout the different phases of these cycles. So we can break this up into the early to mid follicular phase, the late follicular phase and ovulation, the early to mid luteal phase, and then the late luteal phase. So let's start with the early to mid follicular phase. So if we start at the top here, what we see is we have a release of gonadotropin releasing hormone from the hypothalamus that's going to act on the anterior pituitary to release FSH and LH. So starting with FSH, FSH, as we said, is going to stimulate follicle development. And as we see here, the tertiary follicle will begin to develop, which we start to see here. FSH is also going to act on these granulosa cells, which are going to secrete the estrogens, as well as something that's called AMH. And AMH is almost like a negative feedback system that helps prevent the the ovaries, from developing more follicles, so that only one is released and one egg is released at one time. Now, we also have LH that is released from the anterior pituitary. And here, this is going to act on the fecal cells, which are the ones that synthesize androgens. And then androgens can diffuse into these granulosa cells and are converted into estrogens via an enzyme called aromatase. Now, estrogens have multiple different effects in this early to mid follicular phase. One is that it exerts the negative feedback on the gonadotropin releasing hormone, FSH, and LH. But it will also exert positive feedback on the granulosa cells to release more estrogen. So as we can see, we're starting to see a rise in estrogen during this initial stage. So overall, what we're seeing is also this growth and proliferation of the endometrium during this beginning stages of kind of that early to mid follicular phase. Now, in our late follicular phase, and also including ovulation, we're seeing a couple different things happening here. So at this point, there's only one follicle that's now developing, and the granulosa cells of that follicle are dominant, and they're beginning to secrete inhibin, estrogen, and progesterone. So this is where we get that positive feedback phase that we talked about earlier with estrogen. So here we have the gonadotropin releasing hormone still releasing FSH and LH. Now the FSH is going to trigger the granulosa cells to produce more estrogen, and the estrogen has this positive feedback on the gonadotropin releasing hormone, which again is going to stimulate more estrogen to be produced. Now we also have luteinizing hormone coming in, but actually before we speak about that, we're also going to show here that we're starting to have small amounts of progesterone that are being secreted, which we can see here into the ovulation phase here. So progesterone is going to have a positive feedback, increasing the release of GnRH, which is also going to stimulate the release of LH, our luteinizing hormone. So what is specific around this phase is we see what's called the LH surge, our luteinizing hormone surge, and that is really what is going to trigger ovulation. And we also have a smaller surge in FSH. But what we're seeing here is that the reason we don't have such a surge in FSH is that there's also some negative feedback that's coming in. So the granulosa cells also release inhibin, which is creating a negative feedback onto FSH. So we don't see as much of a spike that is occurring here. So this LH surge, as we talked about, is going to help produce oocyte maturation and ovulation. And then when we get to ovulation, this typically happens between 16 to 24 hours after this LH surge. And once ovulation happens, then the egg travels to the fallopian tube. So for this slide, I'm combining both the early to mid-luteal phase as well as the luteal phase. So we'll start with the early to mid-luteal phase. So here we have ovulation has just occurred, and the follicular fecal cells and the granulosa cells are transformed into luteal cells of the corpus luteum. And so now, as we talked about, the corpus luteum begins to be a hormone secreting body, and so it starts to produce progesterone, estrogen, and inhibin, which we see here. Now, what we're seeing is that all three of these hormones can provide negative feedback onto the hypothalamus and the anterior pituitary, so we start to see a drop in both the gonadotropin-releasing hormone, FSH, and LH. So we can see this here by this drastic downturn in LH and FSH. Now, as we go into the later stages of the luteal phase, we start to see some other factors come into play. So the corpus luteum has a lifespan of about 12 days. And so during this late luteal phase, if pregnancy does not occur, then the corpus luteum is going to die and it becomes what's considered the corpus albicans. So as we said, the corpus luteum is increasing the production of estrogen, progesterone, and inhibin, but when it dies, these levels drop, which we start to see here as these declines in these. So because these levels drop, they're no longer exerting that negative feedback, so we start to see this tonic secretion of GnRH and an increase in FSH and LH. Both of these are going to help to support the development of new follicles for the new cycle to begin. A couple other things that we see here. So right after ovulation, we have that rise in our temperature, and that's going to remain stable throughout the luteal phase. Right about 2 days after the corpus luteum ceases function, so when it dies, it turns into corpus albium about 2 days later, so about 14 days after ovulation, that is when that new menstrual cycle starts and the endometrium starts to slough off surface layer and the menstruation begins. So finally here I have a case study which goes through an example of something called functional hypothalamic amenorrhea. Now for the case of time, I'm not going to go through this, but I do have the case study and the key attached to this for you to review with some questions to consider. And lastly, I have my references here for my citations. So thank you very much, and I look forward to hearing feedback on this.